Everyone, welcome back to our channel. In this video, we'll study in detail about the properties of matter and their measurements. Every substance on this earth has its unique characteristic properties. Those properties are classified into two types, physical properties and chemical properties. We'll see about those properties in detail. First one is physical properties. The properties which can be measured or observed without changing the identity or the composition of the substance. To measure these properties, we are not going to change the identity as well as composition of that particular substance. Example of these physical properties are color, odor, melting point and boiling points. For example, you can see if you are asked to tell about the color of any of the flower or any of the substance, you just tell by looking at that flower or that substance, you can tell the color. Means you are not doing any change in their composition or in their identity. By looking only, you are able to tell the color of that particular substance. And also odor. The smell, you can feel that smell and you can tell the smell. Here, while telling about these properties, you are not going to change anything with that substance. So, these properties are known as physical properties. Next one is chemical properties. These require chemical change to happen. There, the substance has to undergo some of the changes. Examples, acidity, basicity, reaction, etc. If you are asked to tell the acidity of particular solvent, then by looking at that solvent, you cannot tell the acidity or basicity, right? To tell the acidity, exact acidity, you have to do some of the tests. You have to perform some of the tests with that particular solvent. Means you are doing something, means you are changing that substance, or that substance has to undergo some change to show its chemical properties. So, these are known as chemical properties. To the properties which can be measured or observed by doing some changes with that particular substance are known as chemical properties. And in physical properties, we have two types, qualitative properties and quantitative properties. Qualitative properties are those which cannot be measured or which cannot be observed easily, like malleability of the metal, ductility of the metal, or shining, you can say luster of the metal. You cannot measure these in terms of units, right? You just feel, and this tells about the quality of that particular substance. So these are known as qualitative properties. Next one is quantitative property. Quantitative means you can tell or measure these in the form of measurements like length, volume, area, density. These all you can measure. So these are, and this tells about the quantity. So these are known as quantitative properties. Okay. Next one is International System of Units. Now we have seen some of the properties, and those properties are explained by the measurements. If you are asked to measure the length of your classroom, what you will tell? You tell about 10 meters. If you tell only 10, it has no meaning. And if you tell only meter, then again also it has no meaning. So whenever for measurements, we require a number followed by a unit, right? So why this International System of Units? What it does is it standardizes the units, and it gave some 7 base units. Those are these are the physical quantities, and these are their SI units. For length we have meter, for mass we have kilogram, for time we have second, for thermodynamic temperature we have Kelvin, for amount of substance we have mole, electric current ampere, and luminous intensity is candela. These are the SI units, means these are standard units. Anywhere on this earth these are standard. You can use, if you go to any other country other than India, there also the SI unit of length is meter only, and SI unit of mass is kg only. Means these are standard all over the world. These cannot change. So that's why International System of Units has made some of the units standard. Okay. Now let us see some of the measurements. Mass. It is the amount of matter present in the substance. Means it is the total number of particles or the amount of matter present in a substance known as mass. For example, 1 kg, 2 kg, 3 kg, these are nothing but masses, and we know that SI unit of mass is kg. Next one is weight. Weight and mass are not same. Weight is force exerted by gravity on an object. It is not the amount of matter present in the substance. So these two are different. And the SI unit of weight is Newton. SI unit of mass is kg and SI unit of weight is Newton. Mass is constant, whereas weight may vary from one place to another place. Mass is constant because the matter present in the substance, it will remain constant anywhere on this earth. But weight may change. If you weigh any of the substance on earth, it will show different weight. If you weigh that substance only on the surface of moon, it will show different weight because of the change in the gravity. So weight mainly depends on the gravity. Okay, so mass and weight are different, and mass will be constant and weight may vary. Next one is volume. Volume is nothing but the space occupied by that particular substance. How you measure the volume? Unit of the volume is length whole cube. This is not the 3, it should come here. It is length cube. Volume is length cube, means length is multiplied 3 times to get volume. That is, and we have for length what we have SI unit, that is meter. So meter cube is the unit for volume. The next one is density. We all know that density is nothing but mass by volume. Mass divided by volume gives the density. Here SI unit of density is SI unit of mass divided by volume, and SI unit of mass is kg and SI unit of volume is m3, that is meter cube. So we'll get kg per meter cube. Kg per meter cube is the SI unit for density. Next measurement is temperature, and we have 3 scales to measure the temperatures. Okay, and among these Celsius, Fahrenheit and Kelvin. Kelvin is the SI unit, and temperature on 2 scales are related to each other by the following relationship. Here Kelvin, here you know the temperature of the substance in Celsius. If you know it is in Celsius, that is added to 273.15, that gives the temperature of that particular substances in Kelvin. Okay, if you are asked to calculate the temperature in Kelvin when Celsius is given, you just add 273 to that, then it will give the temperature in Kelvin. Next one is relationship between Fahrenheit and Celsius. If you have 0 degrees Celsius, then Fahrenheit temperature will be 32. This is the degree Fahrenheit equal to 9 by 5 into Celsius plus 32. This is the relationship between Fahrenheit and Celsius. Now we'll see how those thermometers, we call them as thermometers, right? How they will look and what is the scale of those. These are the thermometers. This is the Kelvin scale, this is the Kelvin scale, and this is Celsius scale, and this is Fahrenheit scale. Okay. In Celsius, we all know that at 0 degree it is the melting point of water, and 100 degree it is the boiling point of the water, and for For the laboratory use, we use the Celsius scale only. And Celsius has negative units also. It shows negative values also, but the Kelvin won't shows the negative values. Here Kelvin starts with 273 and the maximum, that is boiling point of water, is 373. And this is Fahrenheit. Fahrenheit starts with 32 and maximum is 212. Here we know that normal body temperature of the humans is 96.6 degree Fahrenheit. The body temperatures of humans or individuals are expressed in terms of Fahrenheit. This is Kelvin scale, this is Celsius scale, and this is Fahrenheit scale. Okay, these are the three different scales of temperature. This is all about the properties and measurements of those properties. I hope you are clear with the measurements and properties. Thank you. Have a good day.